So energy of a particle executing simple harmonic motion. Energy, it may be kinetic energy, potential energy. First, based on this energy, if we talk about this kinetic energy, where the kinetic energy is maximum? Kinetic energy is maximum where velocity is maximum. Where velocity is maximum? At mean position. What is the maximum velocity at mean position? A omega. Maximum velocity at mean position, A omega. So, and velocity at extreme position, minimum. Okay. And potential energy, if we talk about. So, potential energy maximum at extreme position. Okay. So, that's the next minimum at mean position. Okay. So, next one after this. So, just we are going to discuss about what? It's a first one is about kinetic energy. Next one is potential energy. Next one is what? Total energy. Total mechanical energy. Okay. Total mechanical energy. So, first one, energy of the particle executing SHM, simple harmonic motion. Okay. So, for the first one I'm talking about, this is what? Potential energy. What is potential energy? So, potential energy, you know, for the relation for the potential energy is for the conservative forces. Conservative forces, F is equals to, means for conservative forces, F is equals to minus du by dx. You know this condition already. So, how do you pronounce this? Negative potential energy gradient. It's a negative potential energy gradient. So, this is called what? Negative. Say negative potential energy. It's a potential energy gradient. Negative potential energy gradient is called what? So, conservative force, like this is what? Fc. Okay. So, from here I am talking about this du is equals to minus f into dx. Okay. So, taking integration on both sides. Then what do you say? Integration of du is u is equals to minus integration over what is this? F into dx. Okay. So, u is equals to minus f dx. Now, f is equals to, what is the condition? For the first one is on this. So, u is equals to potential energy. What is this? Minus integration over f dx. Okay. So, what is f? F is what? F is equals to minus k into x. K is called what? Spring's constant. X is what? Either compression or elongation. Okay. So, this f I am substituting here, u is equals to, I can say, integration over minus k x dx. Okay. So, this after the integration, if you go for this minus into minus plus integration over, okay, kx dx. So, this will become as what? K into, what is the condition? X to the power of 1, x power n plus 1 by n plus 1. So, what do you say? This is what? It's a x square by 2. So, this is what? Half k x square is what? It's a potential energy. First question, what is the energy stored in the spring? Energy stored in the spring means potential energy. What is the potential energy? Half k x square. What is the work done by the spring? Work done is what? So, for the conservative forces, when you are talking about this, for conservative forces, this is one case, and next another case also we can go for this. Work done W is equals to minus delta U, negative change in potential energy. It's a negative change in potential energy. It means what? For example, I have this is what? It's a potential energy. What is the potential energy? Half k x square. And what is the work done? Minus half k x square. W is equals to what? W is equals to minus delta U. So, this is energy stored in the spring formula is what? Half k x square. The work done in the spring is what? Minus half k x square is the relation. This is about potential energy. So for the potential energy, now we completed. It's what U is equals to half 1 by 2 k x square is what? It's a U. This is potential energy stored in the spring. Okay. Now potential energy K means what? K. So already you know this is what? K is equals to, we have written m omega square. So in the differential form of SHM also we have completed this one. So this K is equals to m omega x square, m omega square. So U is equals to half, K means what? M omega square x square. Okay, this is the potential energy, half m omega square x square. First question, where the potential energy is minimum, where the potential energy is maximum, and what are their graphs, right? For very first one I'm talking about for the case 1, okay, it's a case 1 at mean position. Okay, this is what? At a mean position. At mean position means what? X is equals to, what do you say? 0. Yes, so x is equals to 0, then U is equals to what? 0. This become as what you say? It's a minimum. Okay, where potential energy is minimum, where the potential energy is minimum? At a mean position, right? And for the second one is that case 2. So the case 2 is, so at extreme position. Yes, at extreme position. So extreme position means what? X is equals to, what do you say? It's a. Okay, x is equals to a. Now we can substitute on this. U is equals to half m omega square a square. Okay, or so m omega square is what? M omega square is what? Half k a square. Half k a square also we can say on this. So what is the expression for potential energy in the spring? Half k x square, half m omega square x square. So next one is about where the potential energy is minimum. Potential energy is minimum at mean position. Potential energy is maximum at extreme position. What is the minimum potential energy? 0. What is the maximum potential energy? So half k a square. Okay, so this is what here about potential energy. Let me know. This is, now I want to know about what is the time dependent and position dependent for everything, for the displacement, for the velocity, for acceleration. Okay, so if we discuss about this velocity, what is the time dependent form? V is equals to a omega cos omega t. Yes or no? A omega cos omega t. Position dependent is what? Omega under root of a square minus x square. Acceleration. Time dependent is what? Minus omega square a minus omega square x. Omega square x is what? Position dependent. In place of x, if you substitute as a sin omega t, it will become as a time dependent. Okay, so same the thing here is that what is the time dependent form or position dependent form? For the first one I am talking on this. So potential energy U is equals to U. This U is equals to, what is this? Half k x square. What is here? X. X means what? It's a position dependent form. Position dependent form. So is a position dependent form. And for the second one is about U is equals to half k. X means what? A sin omega t. Correct na? A sin omega t. In place of x, what to write? A sin omega t. It's a square. So this will become as what? U is equals to half k a square. Okay. So half k a square sin square omega t is what? Time dependent form. Okay. Omega square and t square should not write. It's a theta. Okay. So this is what? It's a theta. We should not write the square. Only, so half k a square total sin square times of it's a omega t. Yes. So this is about position dependent and time dependent. Next one we need to go for the graph. So for the graph is here U is equals to half m omega square x square, R, another one. So then what? Half k x square. Okay, half k x square. So now I'm taking as this is what? It's a mean at this position. X is equals to 0, x is equals to a, and x is equals to minus a. I'm taking this. X is equals to minus a. Okay, so these are the, so from these positions, this is what it's a energy, this is potential energy versus position graph, right? So at x is equals to 0, x is equals to 0 means what? It's a mean position. At mean position, what is the potential energy? In place of x, if you substitute as 0, what is the answer? 0. So it will be 0, right? And next one, at extreme position means the graph will be like this. Okay, so the graph is what? Like at this position it's what? It's a minimum, and at this position this is what? It's a maximum. The maximum is what? What is the maximum? Half m omega square a square. So maximum potential energy at this point is what? Means at extreme position, what is that? Half m omega square a square. Minimum is what? X is equals to 0. That's it. Potential energy half k x square, half k a square, half k 0 square. Half k 0 square means what? It's a mean position. Half k a square is what? At extreme position. Position dependent form is what? Half k x square. Okay. Next condition, potential energy. This is what potential energy is completed. Next I'm talking about, it's a kinetic energy. So kinetic energy. So next one is about kinetic energy of particle, kinetic energy of particle executing SHM, What is the kinetic energy of particle executing SHM? Simple harmonic motion. Okay, so kinetic energy formula. Generally, what is the kinetic energy? So which is in the motion, correct? By virtue of its motion. Okay, so kinetic energy. So first one is that kinetic energy is equals to half m v square. Okay, half m v square. M stands for mass. Whose mass? Mass of the particle executing SHM. V stands for its velocity. So velocity. So what the relation you know about velocity? We have two positions. Okay, first one is about, for the velocity, one is position dependent, next one is time dependent. Position dependent, first one, for example, first one writing time dependent. What is the formula for velocity? V is equals to a omega cos omega t. Here velocity omega under root of a square minus x square. Okay, v is equals to a omega cos omega t. V is equals to omega under root of a square minus x square. Now we can get it as kinetic energy two different forms. So for the first one is about kinetic energy. Kinetic energy K is equals to half m v square a square omega square cos square omega t. Got it? V is equals to, so half m, v means what? A square omega square cos square omega t. So next for the second one is this. Kinetic energy K is equals to half m. What is the V? What is the V? This omega under root of a square minus x square. Okay, whole square. This we can write it as, this is equals to half m omega square times of a square minus x square is what you say? It's a kinetic energy. So this is called what? Time dependent. It's a time dependent. Time dependent means what? At the time t equal to 0, where time t is equals to t by 2, 3t by whatever has given the function. Okay, so time dependent form of SHM. What is that? So SHM, that's what you say, kinetic energy in a SHM. Next one is what? It's a position dependent. This is what? Position dependent. So position dependent form. So like we have the three the conditions for this one is, first one is the kinetic energy K is equals to half m a square omega square cos square omega t. Next one is kinetic energy is what? It's what? Half m omega square a square minus x square. First, I have been talking only two things. First one is what? Position dependent, time dependent. Where it is maximum, where it is minimum. Okay. Next one is about what are the graphs, right? First one, I got the two informations. What is this? First one is time dependent form. What is the time dependent form? Half m a square omega square cos square omega t. Position dependent, kinetic energy K is equals to half m omega square times of a square minus x square. Let me check on this. Where is maximum? Where it is minimum? Okay. So we'll go on. This is what? First one I am talking about case 1. It's a case 1. So for the first case is what? At mean position. At mean position. At mean position means what? X is equals to 0. Okay. At mean position. First. For the next second one is that case 2. At extreme position. At extreme position. At extreme position is what? X is equals to, what do you say? It's a A. X is equals to A. So at mean position, kinetic energy K is equals to half m, which is that position. I'm talking about what? It's a position. I should write the equation of position dependent form. What is the position dependent form? Half m omega square times of a square minus x square. What is the x? What is the x? 0. So what is the condition now? Kinetic energy K is equals to half m omega square a square is kinetic energy. This half m omega square a square. You know, maximum kinetic energy this. So it is maximum. Where it is maximum? Where it is maximum? At the mean position. Okay. So this is what? Maximum condition. It's a maximum. Next one is up. So if you speak about this, it's a at extreme position, x is equals to a, kinetic energy K is equals to, what is the condition? Half m omega square times of a square. X means what? A square. In place of x, what? It's a. So what is the answer? Kinetic energy K is equals to what? 0. So this is what? It's a minimum condition. It's a minimum condition. So why it is maximum and minimum? Just you see, I'm taking as a simple pendulum experiment like this is the bob. Should not take here, the oscillations should not be bigger. Means what? It's a small angle. Small angle. It should make the oscillation like this. Okay. For example, bob came to this position. I brought from here to here. Yes. So its position, this is what you say. It's like it makes an angle theta. So it will come, it will make the oscillation like this one also theta only. No? First, what is the velocity here? 0. What is the velocity? It is there in your hand. What is the velocity? 0. You left it. Velocity gradually increases. Where it will be maximum? Here is maximum. Which position is this? Mean position. The velocity gradually, when you move that, so due to gravity, it's what? Decreases. Decreases, it becomes to what? 0. Velocity becomes what? 0. If velocity is 0, kinetic energy? 0 only, no? Velocity is minimum. So what is the kinetic energy? Kinetic energy also minimum. Velocity maximum. Kinetic energy also maximum. What is the maximum kinetic energy? Half m into V max square. Correct, na? V max square. So this is what? Half m into, what is the maximum velocity? A omega, right? What is the maximum velocity? A omega. So this is what? A omega. Then what do you say? Half m a square omega square. A square omega square. So what is the maximum? Half m a square omega square. Otherwise omega square a square. So this is what it say. Kinetic energy is maximum and minimum positions at mean, and next one is what? It's an extreme position. So I want to represent the graph. Okay. First one. So for the graph is what? Here kinetic energy versus position. Okay, at mean position, this is what mean. Okay, I'm taking about, there are the two like these positions. It's what x is equals to a, x is equals to what, minus a, x is equals to what, 0. Okay, so where x is equal to 0, kinetic energy becomes what, maximum only, na? Correct? So it becomes as what is it, it's a maximum condition. Now this is the case. Kinetic energy maximum at this position. What is this maximum? Half m omega square a square. So what is the kinetic energy at this point? 0. Correct? It becomes as 0, no? Like 0. So we have completed about this. It's a kinetic energy, and next one is about potential energy. Where kinetic energy and potential energy, so our maximum and minimum positions also we have completed. Next one is about what is the total energy, total mechanical energy. Okay, so next one is total mechanical energy. Total mechanical energy. So what is total mechanical energy? Total mechanical energy, it is denoted by what? E. But total mechanical energy I am taking as E is equals to kinetic energy plus potential energy. One thing you need to remember, total mechanical energy is equals to kinetic energy plus potential energy. If kinetic energy is maximum, potential energy should be minimum. Okay, if it is maximum, this should be minimum. It means what? Total mechanical energy is equals to kinetic energy maximum plus potential energy minimum. It's a minimum. So total mechanical energy is equals to kinetic energy minimum plus potential energy what? Maximum. Let me check on this. I'm choosing about this is what? It's a linear oscillation conditions. It's x is equals to 0, x is equals to a, x is equals to minus a. What is the velocity at this position? V. V is equals to a omega. What is the velocity here? 0. Okay. So let me talk about what is the kinetic energy at this position. Kinetic energy Ke is equals to what? Ke is it maximum? Yes or no? What is the maximum? Half m omega square a square. Kinetic energy here is what? Minimum. Correct? Okay, it's a minimum. Let me talk about potential energy. Potential energy at this position is what? Minimum. It's a minimum. Potential energy at extreme position is what? Potential energy at extreme position is what? It's a maximum. You see, at the mean position, which is x equal to 0, kinetic energy maximum, potential energy minimum. Kinetic energy minimum, potential energy maximum. So this is what? Total mechanical energy at mean position. What is the total mechanical energy at mean position? E is equals to kinetic energy maximum plus potential energy minimum. If you want to write at this position, so what is this? This is the condition at extreme position. Okay, so kinetic energy maximum, potential energy minimum. Now total mechanical energy E is equals to kinetic energy plus potential energy. Which is maximum and which is minimum? Kinetic energy is what? Minimum. Potential energy is what? Maximum. Potential energy is maximum. So that's what I'm trying to say. Here one is maximum, next one is minimum. This is what? Total mechanical energy. Let me speak about what is the general expression for this. What is the general expression for here? So the general expression is what? E is equals to, first one I'm writing this one. Kinetic energy maximum plus potential energy minimum. E is equals to, what is the maximum kinetic energy? Where kinetic energy is maximum? Where do you get kinetic energy is maximum? At mean position. So at mean position. So what is the mean position? What is the kinetic energy? Half m omega square a square. So potential energy is minimum at mean position. Yes or no? So you are talking about is nothing but this is what at where mean position. Okay, what is the potential energy at this point? 0. So what is the answer now? E is equals, what is the condition? Half m omega square a square. From this we got it to understand maximum kinetic energy is equals to half m omega square a square. Maximum potential energy is equals to half m omega square a square. Total energy is equals to half m omega square a square. Got the point? So this is, from this we got it understand kinetic energy maximum is equals to potential energy maximum is equals to total mechanical energy. This total mechanical energy is equals to half m omega square a square. So this is what? Half m omega square a square. Okay. Maximum kinetic energy is equals to maximum potential energy is equals to total energy is equals to half m omega square a square. Let me check on this. Sir, for example, what is the kinetic energy? General formula is what? Kinetic energy and the position dependent. K is equals to half m omega square a square minus x square. Potential energy half m omega square x square. Correct na? Isn't it? So these are the position dependent at any position. So here maximum, there minimum, it's not possible. At any position both the energies we need to take it. Okay. So now total energy which means what? E is equals to what? Kinetic energy maximum plus potential energy minimum. Okay, so that means what? One is maximum, next one is what? Minimum. Okay, so this is either mean or extreme. In middle somewhere, in between mean and extreme, somewhere x distance from the mean position, which formula we have to use? This formula we have to use. At any position, okay, at any position is what? Total energy E is equals to kinetic energy plus potential energy. E is equals to, what is the kinetic energy? Half m omega square times a square minus x square plus potential energy half m omega square x square. So this is equals to, you can say half m omega square common a square minus x square plus x square. These two will cancel. This will be what? Half m omega square a square is the total energy. Have you got it? Before what we got it ma? Total energy, total mechanical energy is equal to, what is the formula? Half m omega square a square. Even at any position also the sum of total energies must be equal to same. So always maximum kinetic energy, maximum potential energy is equal to total energy, that is equal to half m omega square a square. So maximum kinetic energy maximum is equal to, we have written this half m omega square a square. Potential energy maximum, this is equal to, what do you say? Half m omega square a square. Okay, so maximum kinetic energy and maximum potential energy and next one total energy are same. So total energy is equals to T is equals to half m omega square a square. Okay. So these are the three cases, so which to be remembered for the problem solving. So carefully you can observe, this is total energy. Okay. Next one, maximum kinetic energy and maximum potential energy. Okay. So let me check on this. This is what total energy, already we discussed it. Total energy is equals to kinetic energy maximum. Okay. So if I use this, kinetic energy maximum is potential energy is what? Minimum. Okay. So this is what, and next one is maximum, next one is minimum. Okay. So for example, if you talk about this one, where kinetic energy is equals to potential energy from mean position, where kinetic energy is equals to potential energy, okay, from mean position, okay, from mean position. So what is the distance from the mean position? So from the mean position, if you speak about, this is what, it's a kinetic energy Ke, okay, is equals to potential energy Pe. Ke is equals to what? Pe. Kinetic energy is what? Half m omega square times a square minus x square is equals to potential energy P is equals to half m omega square x square. Okay. So these three, the terms will be cancelled. Then what do you say? It's what? A square minus x square is equals to x square. Then a square is equals to 2x square. Then x square is equals to a square by 2. Then x is equals to what? A by root 2. Okay. Plus or minus a by root 2. Plus or minus a by root 2. So this is the energy. Total energy is what? Half m omega square a square is the situation, right? And next one, where kinetic energy and potential energy both are equal from the mean position at a distance of x is equals to a by root 2. Okay. At a distance of x is equals to a by root 2 plus or minus a by root 2. Plus means what? It may be left side. Minus means it's a left side, and plus is what? It's a right side. We can use it as. Now, so for example, just I'm taking in a situation. The situation is what? Yeah, kinetic energy and potential energy at every position. At every position means mean position and extreme position. Okay. So from the mean position, kinetic energy is maximum, potential energy minimum. At extreme position, potential energy is maximum, kinetic energy so is minimum. Okay. So at any position means at what position? Like if you speak about at any position means what? The position I'm taking as x from the mean position. Okay. So x from the mean position. Now at any position, if you speak about what is the total energy? Sir, total energy T is equals to what? Kinetic energy plus potential energy. Kinetic energy, total mechanical energy. What do you say? Total mechanical energy is equals to kinetic energy plus potential energy. But total energy, total mechanical energy is equals to kinetic energy is what? So half m omega square times of a square minus x square plus potential energy is what? So this is what? Half m omega square x square. You know, this is, it's a position dependent form. Okay. So for the position dependent form, from this I'm writing as this is what? Half m omega square is common, a square minus x square plus x square. So these two terms are cancelled. What do you say? Half m omega square a square is what? It's a total energy. You see, it not only at the mean and extreme position, at every position, so the total mechanical energy remains constant. Okay. So this is what? X is equals to 0, x is equals to a, x is equals to minus a, some x is equals to something, anyone, some x distance from here. This is what? X. At every position, what is the total energy? total energy is equals to half m omega square a square. Here also total energy is equals to half m omega square a square. So same, if you want to write here half m omega square a square, which we proved here like, okay. So this is what the total energy, okay, total mechanical energy is the sum of kinetic energy plus potential energy. And next one for the graphical representation, okay, means what, how do you draw the graph between energy versus total energy versus position. Already we have drawn this one, kinetic energy versus position, potential energy versus position, okay. So now I am talking about, this is what kinetic energy, total energy means a graph is drawn, it's a graph is. So what is the graph for this, okay, let me check on, this is what it say for the graph. Now graph, so total energy versus position, total energy versus position. So this is my question, means what I want to take about this. Now so this is what position is taken, it's a x, next one minus x. This is what energy, it's a E, okay. So the distances are given like, yes, at mean position, at this x is equals to 0 at the mean position, okay. This is what is the mean condition. At mean position, what energy is maximum? Velocity is maximum. Velocity maximum means what? Kinetic energy is maximum. So the kinetic energy maximum means what? This is what maximum one. The graph will be like this. So this indicates what you say, it's a kinetic energy. Yes. Next one, at mean position. So this is maximum at mean position and minimum at extreme position has shown. And next one, at mean position, which energy is minimum? It seems to 0. Okay. So for example, this is a condition like, yes. So at mean position, potential energy is what? Potential energy is minimum. It's a PE. Yes. So this is what? It's a graphical representation. Yes. For the total energy versus position. So what is the maximum energy at this position? The maximum energy is what? Half m omega square a square. The maximum energy is what? Maximum kinetic energy or maximum potential energy. Both are same. So maximum kinetic energy is equals to maximum potential energy is equals to total energy is equals to what you say? Half m omega square a square. Yes. So next one after this, so just we have completed about this kinetic energy, potential energy and total energy. And what is average energy? Okay. Average energy in SHM. You know, average value. So just let us go for this is what? Average energy. Average energy. Average energy in SHM. What is the average energy in SHM? What is average energy in SHM? See, first one, average value. Just for your understanding, average value. My average value we will discuss in what? Alternating currents. Average, next one, in mechanics also we have completed this one. Average value. So average value of this energy, okay, average energy. But average energy means what? For example, this is the energy. It's what presentation, it's what you say, it's a energy. Next one, average energy. Average energy. Average energy is, it is represented like this. This is the symbol for average energy. Okay. Well, for your better understanding, just I'm giving about this is what? The average value of sine square theta. Average value of sine square theta 1 by 2. Average value of cos square theta is 1 by 2. Average value of sin theta or sin n theta. Average value of cos theta. Okay. These are what you say, it's a 0. Okay, average value of sin square theta 1 by 2, average value of cos square theta 1 by 2. Okay, so these are the things. Now I want to write about this is what average value of kinetic energy. What is the average value of kinetic energy? Average value of, what is the formula for kinetic energy? Time dependent form, because you are writing in the harmonic functions, so time dependent form. Kinetic energy is equals to half m omega square. Okay, half m v square. V means what? A omega cos omega t. Half m omega square cos square omega t. Okay, so half m omega square a square cos square omega t. Okay, so this is equals to, okay, half m omega square a square, average value of cos square omega t. Okay, this is equals to half m omega square a square, average value of cos square theta is what? 1 by 2. So what is your answer now? 1 by 4 m omega square a square. So what is the average value of kinetic energy? 1/4, 1 by 4 of m omega square a square. Similarly, we can write average value of potential energy. Average value of potential energy is equals to 1 by 4 m omega square a square. What is the average value of kinetic energy? Next one, average value of potential energy. Okay, so for the question number 1, model based on this is what? Okay, so I'm giving the situation. After that, let us move to this. Then how do you solve this? But this is what, here x is equals to 0 at the mean position, x is equals to a and x is equals to minus a. Every question starts with a particle starts. A particle is executing simple harmonic motion. A particle executing simple harmonic motion. Okay. So if the particle is executing simple harmonic motion, okay, at x is equals to a by 2. At x is equals to a by 2, what is the ratio of kinetic energy and potential energy is my question. So I'm framing the question. The question is what? When the particle executing, okay, so executing simple harmonic motion, okay, so at x is equals to half of amplitude, at x is equals to half of amplitude, kinetic energy by potential energy is equals to what is my question. Okay, so just you can please try yourself. This is the situation. So when the particle is started from the mean position, okay, so now I'm talking about what is the answer. How do you go for this? Now first one is what? Kinetic energy by what? Potential energy. What is the kinetic energy? Half m omega square times of a square minus x square. Potential energy is what? Half m omega square x square. Okay, now we can try for the simplification. Half m omega square cancelled. So this will become as what? A square minus x square by what? X square. A square by x square minus 1. Okay, so a square by x is what? What is the x is given? It's a by 2. This will become as a square by 4 minus 1. A square by 4 minus 1. A square cancel, will become as 4 minus 1. This is equals to what? 3:1. So the ratio is what you say? It's a 3:1. Yes. So this is the question based on potential energy of a particle. Okay, and so this, it contains about state whether the motion of the particle is simple harmonic or not, and find the mean position and find maximum kinetic energy of the particle. Okay, so first one, let me know on this. Yeah, first what is given the equation for the first question? I'm talking on this. U is equals to 20 plus x minus 2 whole square. Okay, so it is there in joules, right? And next one more has given here. This is 36 joule total mechanical energy. Total mechanical energy E is equals to what is this? 36 joule. Okay, first let me check, state whether the motion of a particle is simple harmonic or not. How do you check the particle is executing simple harmonic? Okay, so simple harmonic means what? A is proportional to minus x. So it's a proportional to minus x. First one, from the conservative forces, you know this is F is equals to minus du by dx. This is equals to minus d by dx times of 20 plus x minus 2 whole square. Okay, so differentiation of constant is 0 minus of x minus 2 whole square means what? 2 times of x minus 2, and differentiation of x is what? 1. Okay, so this will become as what? Minus 2. This total I am considering as a x, right? It's a x. F is proportional to, F is equals to minus 2x. F is proportional to means what? F means what? MA. A is proportional to minus x. Acceleration A is proportional to minus x. So surely we can say it is what? It's a SHM. It's executing simple harmonic motion. Okay, so now this is what? Given condition. Okay, it's a given one. Next, find the mean position. Where is the mean position? For second one I am talking about, it's a mean position. Okay, so for the mean position, when you speak about the mean position, so you know about x is equals to what? 0. Okay, x is equals to 0 means what you say? X minus 2 is equals to 0. X minus 2 is equals to 0 means what? X is equals to 2 units. It is mentioned in meter, so this is what? 2 meter. Okay, x is equals to 2. Where it executes, where it is showing that is what? Mean position, x is equals to 2 meter. Next one, find the maximum kinetic energy. So to find the maximum kinetic energy, you should know about this minimum potential energy. Minimum potential energy is what? Okay, so what is the total energy? Yes, it is given, right? And potential energy U is equals to what? You have U is equals to 20 plus x minus 2 whole square. Okay, it's a mean, no, this term is 0. Then what is the U minimum? U minimum is equals to 20 joule. Okay, it's a 20 joule. Now total energy, total mechanical energy, E is equals to kinetic energy maximum plus potential energy minimum. Okay, so what is the total energy? 36 is equals to kinetic energy maximum plus potential energy minimum is what? 20. So my answer is about kinetic energy maximum. Kinetic energy maximum is equals to 36 minus 20. The answer is what? 16 joule. Okay, so is the situation like these questions will be asking from this.